All right, so square roots. Just like with every parent function, we have coordinates that go along with the parent function. And think about what an actual square root is. What are we doing? What can we not take the square root of? We cannot take the square root of a negative number. So our x values will not contain negative numbers. They will start at 0 because the square root of 0 is 0. What's the next one? Normally we say 2, but don't forget about 1 because you can take the square root of 1. Sorry, not 2, 4. You can take the square root of 4, and you can take the square root of 9. And truthfully, you could go up to 16 and 25 if you wanted to. We'll just use these 4. Okay, so let's graph or plot these points. So 0, 0, 1, 1, 2, 3, 4. And just like with all our other parent functions, if you can't remember points, if you find that this is a struggle for you, just think about what numbers you can take the square root of and transform those. Okay, because if I plug 0 into my function, that's ultimately what I'm doing, and 1, and 4, and so forth. Okay, just like every other parent function, our HK is 0, 0. The x-intercept is the same as the y-intercept. We see this a lot with our parent functions. Domain and range are restricted. And that's because of the fact that you cannot take the square root of a negative number. So for our parent function, the domain is going to be x. Oh gosh, I almost wrote y. Sorry. X is greater than or equal to 0. Or we can say bracket 0 to infinity. For the range, same thing. Y is greater than or equal to 0 or inclusive 0 to infinity. This one actually does not both increase and decrease. As you can see, as we go from left to right, we are increasing from 0 to infinity. We always use our domain values because we're asking, okay, from what x value to what x value are our y values increasing, or are our y values decreasing? Is it 1 to 1? Yes, for every x value, there is one and only one corresponding y value, and for every y value, there is one and only one corresponding x value. The rate of change does vary, and for this one, there isn't an axis of symmetry. It is not symmetrical. If we reflected it, it would be over a line of symmetry, but there's no need to get fancy. There's a minimum for this one. Our minimums are k value. There is no maximum, and there aren't any asymptotes. So there we have it. There's the parent function. Only 4 points to use to transform. Okay, very straightforward. Let's do it. Let's play around with it a little bit. As always, I'm going to add in the version with b so that we can see what that looks like. A is on the outside because it affects our y values. B is on the inside with x because it's affecting our x values. All right, so for this one, our A has a -1, which means we're going to see a vertical reflection right away. All right, and then we don't have a B other than 1. H is -5, which means we go 5 units left. And then K is a +3, which means we go 3 units up. Sweet. All right, so for our A, B, H, and K, B affects the X, but that is 1 minus 5, because that's our value. Now, I can't see. So if we plug 0 in for x, we get -5, and 0 in for y, we get 3. If you plug in 1, 1, you should get -4, 2, 4, 2, -1, 1, and 9, 3, 4, 0. All right. In graphing this, I'm going to go 1, 2, 3, 4, 5, 1, 2, 3. Remember, this does have a vertical reflection, so it's not going to look like our parent function did, starting at 0, 0, and whoa, and then curving up. Now, if you're wondering how do I know where to start and where to go, because these points, there's not a lot of them, you always start at HK. Okay, so for us, we would start at, negative 5 comma 3. Okay, you always start at HK and then you extend out to the next point. So our next point is negative 4, 2. We go in that direction. Okay, don't try to start from the bottom up of our chart. Right here. Always start from HK. Okay, now we do have an x-intercept, but man, I don't know what that is. So we'll just solve for it algebraically since it's not in our chart. I'm going to plug in 0 for y and solve for x. I'm going to subtract 3 to both sides first. Okay, because we're trying to isolate the x and the x is underneath the radical. And then divide by a negative. So we have the square root of x plus 5 is equal to 3. In order to get rid of, wait a minute, we do know what this is. Oh, Patterson. Well, this is good practice. And then we get x is equal to 4, which is in our chart. It's the y-intercept that we don't know. Ay. For those watching this, I am recording this at 6 o'clock in the morning, so that is why I am loopier than normal. Okay, so for the y-intercept, we'll plug in 0 for x. Now, we can't take the square root of 5, so we'll leave it like that, and I'm going to rewrite it in a little bit more proper notation as 3 minus rad 5. Just a little refresher, it is better notation to have the radical at the end. Okay, domain. Domain is going to be restricted from the h value, so x is greater than or equal to negative 5 because there isn't a horizontal reflection, or inclusive negative 5 to infinity. The range. Here we are going less than or equal to the k value. We always go smallest to largest. Because of the vertical reflection, we're going to work from down to up. It's not increasing, our y values are decreasing, so we'll decrease from negative 5 to infinity because that's our domain. It is 1 to 1. The rate of change varies. There isn't an axis of symmetry. Now here, because of that vertical reflection, we have a maximum value, and that is our k, and then we don't have asymptotes. Ta-da! So there's example number 1, technically. I know I call the parent function example sometimes, but truly this is our bigger example. Okay, and then, of course, we have to practice with the b value. But what do we have to remember? Yes, if there's a b value, you must always factor it out before you start your transformations. So we get negative 2 times the quantity of x minus 2. Now our a value is 1, so we're not going to have any vertical shifts, stretches or compressions. Our b is a negative 2. So not only are we going to have that horizontal reflection, but we're going to have a horizontal compression. Remember, it's the opposite from the vertical because what goes into our transformation chart is the reciprocal. So we look at that for the transformation. Our h is 2, so we're going to go 2 units to the right. And then our k is 0, so we actually don't have any vertical translations. All right. Setting up our chart, we're going to have a negative 1/2 x plus 2. And then our y value is going to stay the same. So I can take the square root of 0, so that was my first point, and then 1, and then 4, and 9. Okay, so if we plug in 0, 0, we get 2, 0. If we plug in 1, 1, we get 1.5, 1. If we plug in 4, 2, we get 0, 2. And if we plug in 9, 3, that gives us negative 3.5, which is going to give us plus 2, negative 1.5. Again, 6 o'clock in the morning, trying to do math. Let me see. 4, negative 5.5. Oh, negative 2.5. Sorry. If you're like, don't believe me, negative 9.5 plus 4.5 is negative 5.5, negative 2.5. All right, justification, 6 o'clock in the morning. Yes, I know I tell you guys don't do your math this early, and here I am living by a bad example. Okay, so we're gonna see this go in a different direction because it does have that horizontal reflection. 1, 2.5, 1, 2, 3. So let's say, okay, I'm not really sure. Should my points go left to right or right to left? Always start at your HK, which is 2, 0. The next point we found was 1.5. So we're gonna go this way, which makes sense because of the reflection. But again, if you're stuck and you're not sure, always start at HK. Okay, so HK is 2, 0. There is an x-intercept, and that's in our chart. It's our HK. There is a y-intercept, and that's in our chart. Man, y'all got lucky with this one. Domain. So here, because of that reflection horizontally, x is less than or equal to 2. Okay, we're going a different way. That's my kitty cat if you heard him just meow at me. So negative infinity to 2. Oopsies. And it is inclusive because there's a closed point. We include 2. The range is going to be greater than or equal to 0, or you can say inclusive 0 to infinity. It is not increasing. We are definitely decreasing from negative infinity to 2 because our y values are decreasing as we go from negative infinity to 2. Yes, it is 1 to 1. The rate of change varies. There isn't an axis of symmetry, and because we don't have a vertical reflection, we do have a minimum value, and the rest does not exist. All right, ladies and gentlemen, there is your square root function. Ta-da!